welcome to True Projects. In this video, we are going to explain about the project, which is a machine learning method with hybrid feature selection for improved credit card fraud detection. Before getting into the execution, first I'll give you an overview of the project. So first, we'll know what is credit card fraud. If we have to purchase a thing, we have to make the payment. And to make the payment, there are two methods. We can pay using cash and we can pay using e-payment option. E-payment option is nothing but it is electronic payment. If we pay using credit card, it comes under e-payment method. We all know due to technological advancements, many of them are choosing the method e-payment. Significantly, due to the rise of e-payment, frauds are also being increased. So in this project, we will be discussing about credit card fraud. Credit card frauds are of two types, and they are if a cybercriminal hacks credit card information and does the transactions, it is called as a credit card fraud. And the other method is if a person he steals a credit card and makes the transactions, it is also called as credit card fraud. Because of this, financial loss occurs for both the customers who use the credit card and for the merchants who provide the credit card. So to mitigate this, in this project, we are going to develop a system to detect the credit card fraud. Traditionally, rule-based system and anomaly detection algorithms, these were the existing methods that were used for detecting credit card fraud. But these systems, they face the limitations. And the limitations were they used to suffer with the high dimensional data and they also used to face the problem of overfitting due to irrelevant features. So to overcome these limitations, in the base paper, the author has proposed the method called a machine learning method with hybrid feature selection. What happens in this proposed system is from the dataset, first features will be extracted using the hybrid method called information gain based filtering and genetic algorithm. After features selected, those features will be trained on the algorithm, which is extreme learning machine. This system will detect credit card fraud. But in this project, we have used voting classifier, which is an ensemble technique that combines random forest and AdaBoost to detect credit card fraud. So we aim to predict whether the activity made by the credit card using credit card is a fraudulent or non-fraudulent. And we use accuracy, precision, recall, and F1 score to evaluate all the algorithms used in the project. So to implement this project, we need software and hardware requirements. We need the software of Anaconda, which is application of Anaconda, Python, which is primary language, Flask, which is a front-end framework, backend framework of Jupyter Notebook, database of SQLite 3, HTML, CSS, JavaScript, and Bootstrap 4, which are front-end technologies. And we need Windows operating system, i5 and above processor, 8 GB and above RAM, 25 GB and above hardware. In the project, we have built all these algorithms to compare them with the proposed model, which is voting classifier. We built voting classifier combining random forest and AdaBoost. Voting classifier is a machine learning technique that will combine the predictions of multiple individual classifiers to make a final prediction. Here, each classifier gets to cast a vote on the outcome and final decision is made based on the majority of votes. In the project, voting classifier is employed by merging the predictions of two specific classifiers, random forest and AdaBoost. Random forest, it constructs enormous decision trees during training and aggregates their prediction to make a final decision. It is known for its ability to handle large datasets with many features, and it is robust against overfitting. And we also combine AdaBoost. On the other hand, it is an ensemble method that combines multiple weak learners, which are simple models, to create a strong classifier. It focuses on improving the classification of difficult instances by giving them more weight in subsequent iterations. By combining random forest and AdaBoost in voting classifier, the project aims to leverage their complementary strengths. Random forest excels at capturing complex patterns, while AdaBoost specializes in refining the predictions of weaker classifiers. And this combination enhances prediction accuracy and robustness, making the fraud detection system more effective in identifying fraudulent credit card transactions. So now we will execute the project. To execute it, first we have to open the code folder and that contains source code files. Here we have the code folder of the project. I'll explain you how these files will be used in the project. So the first folder, which is static folder, in this folder we will have files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. These resources are crucial for enhancing the visual appeal and functionality of the project's web interface. Moving on to the next folder, which is templates. Here we will have HTML pages utilized in this project. We will have index.html and about.html, etc. Each HTML file represents a different page of the website and it provides a structure and layout for displaying content to the users. Moving on to the next file, which is app.py. This Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests. We can interact with the database and dynamically generate content that will be presented in the HTML templates. This is the model file, which contains the algorithm information, and it will be loaded into the project code during runtime. Moving on to the next file, which is notebook.ipynb. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is the database file, which will be used for storing the user information. In this file, which is credit card, here we have dataset related to project. This is the credit card transaction data of the customers. We use this data to train all the algorithms in the project to detect credit card fraud. Here, parameters are named as V1, V2, V3, V4, and so on just for the security purpose. In the last column, we have the target variable. We have two different classes, 0 and 1. 0 refers to non-fraudulent activity and 1 refers to fraudulent activity. We use all these parameters. Based on these parameters, it will be detected whether it is a fraudulent activity or it is non-fraudulent activity. So now we will close this file, get back to the code folder. This is the sample file in which we have test cases. These are all the test cases using which we'll be detecting fraudulent activity and non-fraudulent activity in the front end. So close this. Now we will be executing. So now we will copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Here we need to use the command cd following by the space, and now we need to paste the copied path. And now click on enter. Here we can see that current directory is changed to the code folder's path. Now we have to compile the app.py file. For that, we have to give the command python space app.py. And now click on enter. This command will execute the Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser. And this web page is developed using Flask framework. To execute, first we have to sign up if we are new users. So click on sign up and enter all the registration details and then click on sign up. I have already registered and have an account in it, so I'll directly sign in. Click on sign in. And here we have to provide a username and the password to log in. So I'm giving my username and the password. Now click on sign in. I've signed in successfully and I'm redirected to prediction page. Here we can see the parameters. These parameters need to be entered for detecting whether it is a fraudulent activity or it is a non-fraudulent activity. So now we will enter these parameters using the test cases in the sample folder. So here, first we have to enter the V2 parameter. So I'm entering the V2 value here. Now we have to enter V4. So I'm entering V4. Simultaneously, we need to enter all of the parameters. So now I'm entering V5, next V8, followingly V10. So I'm giving the parameter V10. Next V14. So I'm entering V14, V16, V17, V21, V27, V28, which is the last parameter. I have entered all the parameters. Now we will click on predict. So based on the input provided, here we got the prediction that fraudulent transaction based on inputs provided. It means that there is a fraudulent activity detected with the provided input, which are V1, V2, V3, V4, and so on. Now we'll see some more test cases. Click on home. Similarly, we will enter parameters again, but with the other test case. So this time we'll be entering this particular transaction. So here V2 value is minus 0.1204, V4, and then I'm entering V5. Now we have to enter V8, V14, V16, V17, V21, V27, and the last one is V28. So all these inputs, which is V1, V2, V3, all the parameters which are entered, these will be pre-processed according to that it aligns with the trained machine learning model. So now we will click on predict. Here, based on the provided information, we got the result that non-fraudulent transaction based on the inputs provided. It means that non-fraudulent activity detected. We'll enter some more parameters. So click on home. I have entered all the required parameters and these will be pre-processed by the model. Now click on predict. Here we got the prediction that there is non-fraudulent transaction detected based on the provided input. Now we'll try using the other case. Click on home. I entered all the parameters of the other test case, which is the transaction. Now click on predict. So here, based on the provided details of the transaction, here it has been detected as fraudulent transaction based on inputs provided. Now click on sign out. In this way, just by entering the parameters, which are the transaction details to the system, we will get the detection whether credit card fraud detected or not. That means it is a fraudulent activity or not. I forgot to show you the comparison graph, so I will log in again. If we click on about link, we can see the comparison graphs. This is the count bar plot on which x-axis represents the two classes which are fraudulent and non-fraudulent classes, and y-axis represents the number of transactions that fall into each category. Here, 0 is non-fraudulent transactions and 1 is fraudulent transactions. Fraudulent transactions are represented in orange color and the non-fraudulent transactions are represented in the blue color. Coming to the next graph, which is accuracy comparison graph. In this graph, x-axis represents accuracy score of each algorithm and y-axis represents all the algorithm names. Generally, accuracy is the ratio of correctly predicted instances to the total number of instances. It provides an overall assessment of the model performance considering both true positives and true negatives. Moving on to the next graph, which is precision. Similar to accuracy, in this graph also, x-axis represents precision score of each algorithm and y-axis represents algorithm names. Precision, it is the ratio of true positives to the sum of true positives and false positives, and it assesses the accuracy of positive predictions, specifying and identifying how many of the predicted positive instances are actually positive. The next one is recall. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the sum of true positives and false negatives. It measures the model's ability to identify all relevant instances, capturing how many actual positive values were correctly predicted. The last one is FN score. Accuracy, precision, recall, and FN score are the metrics that are used for evaluating all the models in the project. We can observe that voting classifier is performing well, which is proposed algorithm. Now click on sign out.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.